To another SME Media webinar. I'm David Muller, Senior Editor. Today we will explore the topic, Implementing Mobile Robots is Easier Than You Think. This presentation is sponsored by KUKA Robotics, and we are lucky to be joined by Denise Stafford, the company's Business Development Manager. And before I turn things over, I'd like to review a few housekeeping items for our attendees. If you look to the right side of the screen, you'll find a question and answer box. If at any time during the presentation you'd like to ask a question, type it into that question and answer box and we will answer it at the end of the presentation. If we don't get to all the questions before the webinar wraps up, any unanswered questions will be responded to via email. Also, if you experience any technical issues like a loss of sound, please also use that Q&A box to alert us and we will respond to you individually with a suggested fix. If you're not able to regain access to the live webinar, or if you have to jump off early, this presentation will be available in recorded form at about 4 p.m. Eastern today. You can watch the webinar as many times as you like. All you need to do is sign in with the credentials you used today. Also, feel free to share those credentials with colleagues who may benefit from this topic. Now, it is my pleasure to turn things over to Denise. Welcome. We're happy to have you join us today.
Thank you, David. So let us get started immediately. Let me share my screen here. Okay, let's do this, let's do that, and let's do this. So welcome also from my side. Implementing mobile robots is easier than you think. As David mentioned, my name is Denise Stafford. I'm with KUKA Robotics for 16 years now, and I joined the mobile team about 10 years ago. KUKA is doing mobile more than 10 years, but 10 years ago is when I joined the mobility team. First, just a few words about KUKA. KUKA is an established company. We are 125 years old this year, so we celebrated that. And we are in robotics since robotics is a thing. We are a global company with over 4 billion in revenue, represented in 50 countries, and have about 15,000 employees. And of course, we support you wherever you are. For North America, we approach this cross-border seamlessly. So if you're in Canada, US, Mexico, all three of them, we are focusing on you. Now let's get started about integrating KUKA AMRs. I divided this in 4 different parts. First, I would like to talk a little bit about the basics. Then I will guide you through what do I have to think about if I think about my process. I will say a few words about software, and then everything that did not fit in any of these 3 categories, I summarized under other considerations. So let's go started with the basics. What I mean with the basics is, think about what is the best robot that can do the job. So first of all, you have something you want to transport. So think about the physical dimensions, the weights, and the center of gravity of your part. How do you get it safely on the robot? How do you secure it? How do we get it safely off? For that, you have some help in our specifications and in any other suppliers too. You will find center of gravity diagrams, and I highlighted a little bit. It depends also on the weight you have and how much you lift. So there are things you can do. You can also reduce the speed if the center of gravity is a little bit out of that. So we can support you if it doesn't really fit into the diagram, we can help you. Also, if you think about the dimensions, if you have a part that is a little bit bigger than the footprint of the robot, which will otherwise fit, you can do some overhang. So don't shy away only because it's bigger, so you can work with overhang of the load over the mobile robot. So we do have a whole range of different robots featuring different payloads. So we started about 600 kilograms, and we can provide everything up to nearly 100 metric tons. And then in case you have a specific application that needs it, we also combine our robots, our robotic arms, with our mobile platforms. Next, after you clarify that, you might want to think about how accurate the mobile robot have to be, or your application, what does it need, right? So how accurate does it have to go underneath something or close to something to hand over the part? Even though there are a lot of sensors out there and there's an inherent accuracy of the platforms too, don't forget about simple mechanical solutions. Sometimes a cup and cone mechanism might be perfectly fine. There are some features that our mobile robots have that might help you in case the standard laser scanner positioning is not accurate enough, or laser scanner positioning depends a lot on the environment. And if the environment doesn't really fit for what you want to do, how can features help you? So first of all, there is a QR code camera on top of the AMR that looks upward. You can use this to identify the load, but you can also use this to find position underneath the rack, because this is exactly where you actually need the higher preciseness, right? So that you can be sure that the rack can be lifted up precisely. But sometimes you might not even have a rack. So we also have a QR code camera that faces the ground. You can use this to navigate, but you can also use this to find precision. So you only put the QR codes wherever you need this higher precision, and with that you can achieve what you need. Now, the other thing you might want to think about is you have the robot, you have maybe some tooling, you have the part. So how do you interface in between these two components? What interfaces do you need? Electrical, mechanical? There are some interfaces that we provide. So first of all, we do provide integrated lifting models, but maybe you need something else. Maybe you need something more customized. Maybe you need a roller conveyor. Maybe you need a customized lifting model because the one we provide does not fit to your application. Or you have a racking system. So for that, we have fully customizable interfaces with outputs, with e-stops, with communication, and then there are mounting holes. So these are examples of interfaces that helps you to build your application. The next point talks about the environment. We are now entering the floor. We are driving around. So of course, the first thing you might want to think about is, how are my floor conditions? Are there obstacles? Is there a lot of liquid on the floor? Are there holes or gaps or ramps or some unevenness? To help you to identify this, in each of our operating instruction, you will find a section about floor conditions. And if you're not really sure, even after looking at the floor, looking at the specifications, just ask us, have us come on your floor, have a look ourselves, bring a demo unit in, and let's just test if it works or not. The other environment component is the air, so to speak. Is it dusty? Is it specifically hot? If it's very cold, or does it need a certain cleanliness? So you also want to think about the environment in this, under this perspective. So we do, first of all, provide, nearly all of our mobiles have IP54 to, right out of the box, have a robot that can withstand manufacturing environments, for example. We do have one little example. This is the 600W. This is meant to run in a warehouse. In a warehouse, the conditions are a little bit different. So this has IP20, but everything else you see on this screen has IP54. And then sometimes customers want to bring a mobile robot in a clean room. So as you can, for example, see here with the camera AC, it also comes in a clean room version. So we have sometimes certain specific versions for specific environment conditions. Then The next question you should ask yourself is, how much space do I have? Does the mobile robot fit where I want it to drive? Do I need two robots passing each other so that I can have the throughput I need? So space is something else you want to think about. When I think about space, I also think about what are the driving capabilities of the mobile robot. Generally speaking, most in the market, you have either differential-driven mobile robots or omnidirectional. Differential drive is mainly driving in one direction, forward or backward, and then you can turn on the spot. It can also do some curves to some degree, but this is the main concept. You go in one direction, you turn on the spot, and then you continue driving. Specifically, when the platforms are getting bigger, it is very of advantage if you can do a sideways motion. So this is the main motion that if you have an omnidirectional vehicle, what you might need. Omnidirectional really means you can go in any direction. As you can see here, our smaller units, because that's typically where you are able to do all your applications with a differential-driven platform, have differential drive systems. And then as soon as the payload increases, of course, the platform size is bigger too, then we switch to an omnidirectional movement. Also talking about driving and navigation, we now drive around the floor, so the robot has to have something it can reference against. So typically the laser scanners that you have there for safety are also used for navigation. Laser scanner navigation need unique and stable features in scanner height. And they cannot work with reflective, polished, transparent, or deep black surfaces. So if you don't have the surfaces that I just mentioned, if you have stable features, we can have some instability and change in the environment, then you're good to go. If not, you might want to consider using the feature I explained earlier. So I told you that we have a QR code camera that faces to the ground when I was talking about fine positioning. You can also use the same camera to navigate. So if you have areas where the laser scanner navigation might not be working or good enough, we have, for example, a very often changing environment, so you're missing the unique features, or you're unclear about the surfaces, you can add in these area QR codes and then navigate on that. Next is just something to consider. There is an inherent safety system that will stop the robot anytime someone passes it, right? But you also want to have an efficient running mobile robot. You don't want to have it stop all the time. So you might want to consider dedicated driving path for the mobile robots, and then other paths for pedestrian or forklift drivers, for example. So that concludes the basics. Now let's talk about the process. So you want to automate something that was manual before. So sit down with other people and really describe the process and divide this into subtasks. For example, you want to pick up from A, you want to transport it to B, then you want to handshake with the machine to then drop off at B. Really make sure you understand all the manual tasks that you need to automate, that you don't forget anything in between. And then think about the process flow from a mobile robot perspective, because now you're a mobile robot, so to speak. One of the questions you might want to ask yourself while doing this exercise then is, my mobile robot is driving around. where can it best be charged? If you have a workstation or within your process a step where the robot can stand or will stand anyway for a couple of minutes or longer, you might want to consider charging within the process. Or for your application, it's better, let it run for 2-3 hours and then send it to charging. So that's really application specific. A few words about safety, and mainly I would say risk assessment, right? So perform a risk assessment, like with any kind of automation, look at risk factors like what's with interaction with humans, what about the interaction with other equipment, if something fails, what could happen, what are my environmental conditions. And as with any other robotics application, there are safety standards out there, also for mobile robots. For example, the R1508, which, for example, has a nice list of possible hazards you can go through. And then, yes, mobile robots come with an inherent safety features, so it will stop to not harm a human. But you really have to think about the whole application. The whole application needs to be safe. And there are some features that will help you when you build your safety concept. First of all, depending on the type of the robot you're looking at, it comes with either 3 or 4 3D cameras that can detect everything that's above or below the laser scanner, which are only scanning in a 2D plane, right? So it covers a broader field so that you can identify, for example, overhanging objects. Then what I mentioned several times before, it does come with a safety lidar detection. It's important to us to cover always 360 degrees around the whole mobile platform. The scan fields, you have multiple scan fields, which will then expand the faster you drive, so it's speed defined. And generally speaking, you have a 3-meter scan radius. But sometimes, as soon as you enter a station, for example, you have to shrink the safety field up until you might have no safety field. So for that, we also provide safety bumper. So these are physical e-stop safety bumper that cover all sides. So for the last inch, so to speak, there is a physical bumper that helps you with your safety concept. And then there are e-stop circuit located in all 4 corners. This is a physical e-stop button. Now, let's look a little bit into software. Software is really the key to have a good running application. It has to talk to everything, it's mobile, so you really have to make sure that everything runs smoothly. So as a first step, think about all the different parts that have to talk to each other and with the mobile robots. What are the information flows? Also, the robots are mobile and they communicate via Wi-Fi. So you might want to check your Wi-Fi coverage. And then, generally speaking, think about everything that's still on paper or where you rely on a person talking to another person, any kind of non-digital information you have, but that need to be digitized for automation. Now let's talk about the mobile robot application software. So first I want to show you kind of the key things that a mobile robot application software does. So first and foremost, the mobile robot has to understand what it has to do. So something, typically a software, can also be an HMI where a person clicks something. Something has to give an order and then forwarded to the mobile robot. So the mobile robot application software needs to receive orders, process them, execute them, and then prioritize them. And of course, it has to manage all the mobile robots. So it does fleet management, right? It controls, it monitors, and plans the routes of the AMRs. Also, there are signals that have to be processed from external systems or also internal inputs and outputs. And last but not least, we are in the world of data. The same is true for mobile robots. There's a lot of data that is created that has to be processed, and that also have to be supplied so that you can externally monitor some of the data, use the data for external monitoring. Now I have a little overarching video to give you a better understanding how the KUKA software works. So the software is workflow oriented. So you are in a software and you think about your workflow and you go through this. So you see here, you don't code, you put together all the tasks you have to do. We can help with a multi-brand fleet. The software keeps track of location, direction, and speed of all the different devices that are connected, and makes sure it takes care of the traffic control so that everything runs smoothly. It also uses a fleet management system that manages the peripheral. So all the different systems you have to work with. So that was just a little intro, so to speak. Now let me highlight a few things here in a little bit more detail. So you do have a fleet dashboard that gives you always an overview what the status of your application is. So you see the map, so you can monitor the map. This dashboard is fully customizable to your needs. Things you might want to look at. You might want to know the total travel distances, operational uptime analysis, on-time task statistics, charging ratios, or fault reporting stats. So these are just a few things you might want to have ready, available all the time, so that you look at it and you know. Secondly, the control system. So you have a software that helps you with mapping. So mapping is the process when you create this map, as you see here. So these are all the different spaces the mobile robot can go. It's a graphical configuration, as I told you before. So I always explain it that you learn how to use the software instead of learning how to code. So after you understand the software, you are able to do all this. You have a real-time visualization, and the software takes care of all the path planning. You don't have to worry about that. It can interact to peripheral devices. It also does order and traffic management. And then you can define zones where certain things or certain rules apply. So you might want to have a zone where only a specific type of robot is allowed to go in there. Or you might have a zone where no robot can go in there. Of course, this software supports all the different KUKA robot types, but also if another mobile robot supports VDA 5050, we can integrate this robot easily into our system as well. And then if I kind of mentally go back to the beginning of your project, when you start to think about your application, you might want to think about doing a simulation about the fleet, about your application. So we support you with that. So we can do a full system simulation. We can do cycle time analysis, AMR count determination. We help with traffic and task optimization and to understand your process. So this is something we provide as well. Now let's think about other things you might want to reflect on. So first of all, really think about, specifically if it's your first project, how do you learn? Look around, you know what you roughly want to do, so research how others did this. There might be similar application out there. Maybe it's in other industries, but there are other companies that might have already done something. Also make sure to pick the right partner to collaborate with you. Specifically, if it's new to you, you might want to partner up with someone who has made more experience with doing these kind of applications. I brought you some examples of what customers or some of our customers did do with our robots. First of all, palletizing. So at the very end, the end of line palletizing, somehow this pallet has to go places. So some customers do pick up the pallet, either only the pallet or the whole regular pallet, and then to bring it into an inventory area. You might think about line tending. So bringing parts to an assembly line, bringing parts between workstation, from a workstation area to an inventory space. So line tending is something a lot of customers are thinking about and implementing. You can also connect complete robotic cells. So in this video, what you see is there's a whole welding process. So these are truck cabins that are welded together in different robotics welding cells. And you see here, the mobile robot is the connector between all these cells. So it's driving into a welding cell, the welding happens, and then it takes the part to the next step. Another application that's very common, I don't think it's an official word, I call it mobile conveyor. You might already use a lot of stationary conveying, but then there comes this point where there's just a lot of miles of conveyance. So instead of putting a lot of miles of conveyance, and maybe you already use forklift trucks, you can put a conveyor on top of an AMR and then use the AMR as a kind of a mobile conveyor, right? Another application is, I mentioned before, our 600W. W stands for warehouse. Even though this application can also happen in production, bringing racks to assembly workers. So bringing whole shelves or racks to people, that's another application you might think of or ask us for people who already did that, and then we can connect you. And then generally speaking, every time you have to transport something within your factory, you might want to think about using a mobile robot to bring it from A to B to C to D. And then what do people do if they put a robotic arm on top of the AMR? The first example you see here, packaging material exchange. It's taking this packaging material and then put it into the machine, put the empty rolls off the machine. So these are tea bag packaging machines, so they package tea. And you see in a second, so it picks the full roll of packaging material, drives it over to the other side. And even though this looks like a simple application, if you do it every day, it's only 5 kg, but you might get tired. They have resulting quality issues out of that. So that's one experience, any kind of packaging material. Laboratory automation is something people do with mobile robots, which is nice because in this case, in a lab environment, the machines are not really ready at all to automate. So having a robotic arm that can be used like a operator arm helps with combining all these machines. 3D printer unloading, something customers are thinking about and doing. And then any kind of machine tending. You see here a mobile robot putting or changing tools of a machine. You can also take parts out of a machine into another machine or in an inventory area. You get the idea. In the middle down here, in this application, the robot picks tools out of a warehouse and then brings it to a production environment. And you see here, this is a big robot. You might wonder, how do you do the safety? So first of all, it stands still while the robot is moving. So you can use the laser scanner that are here now to stop the robot instead of stopping the platform. Also, it is set up with the safety PLC. So if the platform is driving, the robot will never move. So now you see here the robot is in a home position. It's stored. It's like you're having a payload on top, right? And then when it stops, the PLC switches, and then the platform will never move as long as the robot is ready to go. And then as last of my examples, customers use the robotic arm on a platform to do quality inspection and be way more flexible with now having the mobile platform underneath. And then when you start a project, you might want to think about starting simple and then adding complexity later. I know it's not always possible, but if you can, it might help you with learning how this technology is being used, how the people that are working in this environment react to the mobile robot, and so on. And this is just a little overview about what do I mean with more simple and more complex, right? So for example, if I look at the route, if you're always driving the same circle, then that's probably simpler than if you have a very flexible flow and sometimes the robot has to go left, sometimes it has to go right. You have 20 different machines. So this is more complex. The same if you only transport a thing or if you have a robotic application on top. I mentioned the environment earlier. If you have a relatively stable environment, it's easier to integrate than if everything is constantly changing. Even though, as I mentioned before, you can add the QR codes, so it might actually not be that more complex. The more traffic you have around you, the more pedestrian, forklift, or other vehicles, the more complex it will get. Human interaction, machine interaction, if you don't have any interaction, it's simpler than if you have to have a lot of interaction. And then I also mentioned before, if you already have everything available digitally, if you already have if you have software or machine with interfaces, then it's just simpler to implement than if you have to create all this. And then if you're now thinking about, okay, I considered all this, now what's with money, right? So of course, everything has to make economic sense, but there are some things I want to give you that you might want to think about. That's not always super easy to quantify. So first of all, if you have mobile robots, you can improve your workers' ergonomics and safety, which leads to higher product quality. I highlighted in the videos the role exchange application. Of course, if the person who's doing this the whole day up and down and on your knees, then the worker might get tired and then it leads to some quality issues. And then depending what you use or how you use things today, adding a mobile robot might save you space. And also now we're creating a lot of data. So that might help with optimizing your process, optimizing traceability of the while you're building the product, for example. Using mobile robots can give you an easier access to machines and other equipment compared to, I mentioned before, conveyor belts or linear tracks. It's mobile, so you don't block a machine unnecessary. And then something not everybody is thinking about, but it's tougher and tougher for companies to attract young people to work in manufacturing. So every piece of technology you bring into your environment might help you to attract younger people, which we will need in the future to do the work. And then just as a summary overall, why might you consider now using a KUKA mobile robot? So first of all, we are 125 years old. We speak automation. We have a whole automation portfolio, right? So we have platforms, we have mobile robots, we have standard robots, specialized robots. We have actually over 300 different variation of robots. We are used to have products that are in tough environments. So it's really made to last. So we use industrial proven components. We make it as maintenance friendly as possible. You have work instructions, how to change parts, trainings, etc., etc. And as I mentioned also before, all of our mobiles have IP54. Wherever you are, we are there to support. Globally, locally, we have experienced and highly trained engineers also for the mobile space. We have a whole engineering team here in North America, specialized in this area. We have a 24/7 focus center. So whenever whatever happens, you have a phone number you can call, and someone will pick up or call you back within 30 minutes. And we have a global network and resources we can draw on in case we have to. Now, talking about the mobile part, we have a no-code software ready to build your application. So as I mentioned before, you learn how to use the software instead of learning how to code. The software, it has a powerful workflow management suitable for all KUKA mobile products as well as other systems. It fits if you have a new operation, if you have an existing operation. We have flexible drive system, different navigation option. All these things help you to integrate it in an existing environment. We are ready for safe applications. What I did not mention before is all of our controllers and sensors are safety rated. And then it's a KUKA product from beginning to end. It's an end-to-end product. It's developed by us. It's manufactured by us. It's sold by us. That was my presentation. Thank you so much. And I think I hand it over back to David.
Thank you, Denise, for such an insightful and informative presentation. It looks like we received some questions from our audience. Quick reminder to our attendees, get your questions in now while we have our expert on hand. Our first question, you mentioned support for simulation. Is there other support from KUKA that I can get?
Yes, there is. So I explained to you how do you pick your robot? If you say, yeah, Denise, you're nice and you give me a good presentation, but I need more help, we are willing to get out, right? We have a whole team of engineers and sales people that help you, first of all, to pick the right robot. We can give demos at your customer floor, or we have demos in our headquarters in Shelby Township. We do feasibility studies. We try to connect the right end customer with the right integrators. We have a good network for that. We do training, application support if you need help with programming, if you want to have a maintenance contract. So all the support you can think about robots, we also provide for mobile robots.
Okay, quick reminder, get your question in now while you can. Next question, if something is blocking the way, can the AMR drive around it or does it just stop in front of it?
Actually, that depends on what you want. So it can just stop. You can have it drive around. You just want to have a little bit of deeper thought about what you want to achieve and what your situation is. What I mean with that, it's nice to think about, oh, I just drive around all the time, but you want to drive around safe, right? You have people that are in the area, so you need the space to actually do this. And then you also want to be efficient. So it might take the robot a little time to drive around and then find back. And so you might want to stop the robot, send a signal, and someone has to be the annoying job to put the stuff out of the way. And after he did it the 10th time, he might not put it there the first place, which he shouldn't. So simple answer to the question, it can do both. It can go around or stop, but you have to think about what is best for your application.
Okay, excellent. I'm not seeing any more questions at this moment, so give another second. Okay, well, I want to thank Denise for joining us today. I also want to thank our attendees for your participation. We hope you found the content valuable and will join us again soon. Until then, remember that SME and SME Media are here to help you stay up to date on all things manufacturing. You can find links to podcasts, webinars, publications, and news by visiting us at advancedmanufacturing.org. Thank you.
Industrial intelligence.